A very warm welcome to all. Welcome back. In this video, we'll be discussing about hands-on ACL. So we'll be doing hands-on session using CISCO Packet Tracer with the concept access control list. So in the last video, we discussed about various commands, various syntax, and what is actually the access control list. So in this video, we'll be discussing and we'll be doing the hands-on session using the CISCO Packet Tracer tool. So this is the network what we are going to do today. We'll see once what we are going to do. So we have a topology, and the topology consists of three different networks: 192.168 1 network, and 192.168 2 network, and 192.168 3 network. And 1 network is having 4 PCs, and 2 network is having 2 PCs, and 3 network is having 2 PCs. And what is that we need to do is we need to write some ACL statements such that 192.168 1.1 should not communicate with the 2 network, and 192.168 1.2 should not communicate with the 2 network, and 192.168 3 network completely should not communicate with the 2 network, and to permit all other routes, which means that this 1.1 should not communicate with the 2 network completely, and 1.2 should not communicate completely between the 2.0 network, and this 3 network, both 3.1 and 3.2, whatever it may be, complete 3.2 network should be blocked. The communication between the 3 network and the 2 network, and all other routes should be enabled. So this is the condition which is given to us. Now what we have to do, two things. One is we need to find out on which router we are going to write the ACL statements, and which port or which line we are going to choose it to implement the ACL. So let me assume that I am choosing this router 0. If I am choosing the router this 0 and I am writing the ACL on this router, what happens? So 192.168 1.1 will not be able to send any packets out of this router. So my first statement will be will be fine. Second, 1.2 should not communicate with the 2 network, so it is blocked here itself, it will not go. And the third condition is 3 network should not communicate with the 2 network. Is it possible? No, because 3 network, we are doing the ACL in this router. In that case, this 3 network can easily communicate with the 2 network. It is not blocked, so I cannot choose this router to do my ACL. Next, I'll choose this router. I'll see if it is possible with this router. Okay, so 3 network, it will not go, whereas 1 network we cannot block, correct? So I cannot do on this router. Let me see in this router. In this router, if I am writing the ACL statements, so 1 network cannot communicate with the 2 network. Similarly, the 3 network can also communicate with the 2 network. So this router is very apt to do my ACL statements. And which port should I choose? Should I choose this port or this port? Because since we have studied that during the classes, we have seen that implementation should be done closest to the destination in the case of standard ACL. Since we are doing the standard ACL, the implementation should be done. This is my destination, so my implementation should be done in this line. So then the gigabit 0 by 0 in this router, I should do my implementation. Okay, so whether it is in or out, that I should decide. Okay, because now since this is my destination, it is in the out direction. This we should decide it properly. So with this, let us do the implementation portion using the CISCO Packet Tracer tool. So I have taken the CISCO Packet Tracer tool from the scratch. We'll do it today. For that, let us build the networks now. We'll take some routers of 1941 I'll take 3 routers of 1941 since I have 3 networks and 3 routers is being given in my topology. I'm having 3 routers. I've taken, placing it. Then I'll take some 3 switches of 2960, the basic switch I'm taking. Okay, so the basic switch can be used for all the lower level information transfer. I can use this basic switch, and as per my topology I have some 4 PCs in the case of first under the first router in the 1.1 network, and in the 2.1 network I have 2 PCs, and I'll take some 2 PCs under the 3. network. Okay, and I'll connect all these things using cables. So copper straight through cable, I'll take Ethernet port 1, I'll connect it to the first PC, and I'll take a second cable, I'll connect it to the Ethernet port, and I'll take one more cable of fast Ethernet ports and connecting it here, and the last port to be connected with the fast Ethernet. Yes, it is done. Similarly, I'll do for this network also. I'm just connecting the cables, not doing anything. Okay, since you from the scratch I'm doing, you'll be able to easily follow. If you don't have an idea to do this routing also, I'll be doing it from the beginning only, so you will be able to follow it. Yes, so now to connect the switch and a router, always I'll be using the gigabit Ethernet port. You can use the fast Ethernet port, but I'll always use the gigabit Ethernet port so that data transfer will be good. Gigabit Ethernet 0/0. I'm connecting all the gigabit Ethernet ports. Yes, done. So between the routers I'm going to use the serial cable, but now as such I cannot go with the serial cable. I should have a serial ports, at least since I'm discussing about the ACL statements. If my network is scaled up, I'll need to connect some more routers. So now itself I'll try to add those modules. I'll go to the router, I'll switch off this router. Okay, I'll take some HWIC2T, I'll place it HWIC2T of 2 modules so that I'll have 4 serial ports. Turn it on, close, again go to the second one. Okay, turn off the switch, HWIC2T of 1 will have 2 serial ports, totally 2 I'm using, so 4 serial ports I can get. Turn it on, next one, turn off this switch. I'll take some HWIC2T of 2 numbers, so I'll be having the 4 modules. Now it is done. Now I'll be able to connect these serial cables easily. I'll always choose with 0/0/0 to connect between the router 0 and router 1. Then again I'll take some 0/0/1 to connect between this routers, 0/0/1. Done. Now let me place node. Okay, so this is going to be the 192.168.1 network, and this is going to be 192.168.2 network, and this is going to be 192.168.3 network. Correct. So this one will be 10.0.0.1, and this side it is 10.0.0.2, and here it is 11.0.0.1, and here I'll go with 11.0.0. Okay, what happened? 2. Okay, so accordingly I'll have this network 192.168.1.1, 192.168.1.2 and 192.168.1.3 and 192.168.1.4, and here I have 192.168.2.1 and 192.168.2.2. okay, then here 192.168.3.1 and this one is 192.168.3.2. correct. So here this side I have already having the IP address. For this side the gateway 192.168.1.100 and similarly it is 192.168.2.100 and here it is 192.168.3.100. I have taken all these things. So my default gateway is 192.168.1.100 for this network, 2.100 for this network and 3.100 for this network. I'll go into the PC and give all the IP addresses. I'll proceed with that. Okay, I'll go to desktop IP configuration. So it is 192.168.1.1, followed by this I'll give the gateway address 192.168.1.100. second one is 192.168.1.2 and the gateway is 192.168.1.100. correct. Next PC it is going to be 192.168.1.3 and the gateway is 192.168.1.100. so this gateway should not make mistake. okay, so once we do all these things, first place a note what are the topologies, what are the IP addresses we are going to give, write it down. Though we are experts in doing, writing is always good so that you will be able to do it without mistakes and it look good also. correct. Yes. 1.100, close it. Now second network, it is 2. network. So 192.168.2.100 2.1 and the gateway is 192.168.2.100 and 192.168.2.2 and the gateway is 192.168.2.100. correct. Now next we'll go to the 3. network. In the 3. network it is 192.168.3.1 and gateway is 192.168.3.100. correct. Next 4th PC it is going to be 192.168.3.2 with a gateway of 192.168.3.100. good. We have completed giving the IP addresses and gateway for the PCs. I need to do it for the router. I can do it in 2 modes. One, it can be done in the configuration mode, other I can do it in the CLI mode. I'll go with the configuration mode. okay, so gigabit Ethernet port. So this port, what is the IP address given? 192.168.1.100. so subnet mask, it will come automatically, then we need to turn on so that it will go into non-shutdown mode. Then in the serial port it is 10. network 10.0.0.1, it is a class A address, so the mask is different. Then we need to go to settings and save. It is done. okay, and I'll assign the routing protocol also. I'll assign it here. So it is 192.168.1. network. I should add it. Then what is the next one is 10.0.0.0 network. I'll add this. So I'm using this RIP protocol only, so I'll save this also. Yes, it is done. Next I'll go to this router, I'll go to configuration mode. Okay, in the configuration mode I should go with, give the gigabit Ethernet port 192.168.2.100 is that, then turn it on. Then serial port 0 bar 0 bar 0, it is 10.0.0.2 turn it on. Then I'll save this. Then routing, what is that, 10 dot network should get added. Okay, and then we need to add this 192.168.2 dot network to be added. Okay, and one more we have the other wing, that is 11.0.0.0 network to be added. I have added, but here I have not given the serial port, it is to be given. So 11.0.0.1, correct. I'll save this. Then I'll give this 0.0.1, 11.0.0.1. Yes, I'll turn on this. I'll go to settings and save this. Yes, done. Now last router is gigabit Ethernet port, it is 192.168. Yes, it is 3.100. very good. With that subnet mask I can add it, and one more port is there, right? That is serial port 0 bar 0 bar 1, it is 11.0.0.2. okay, I should turn on this also. I'll go with settings and save them. Then RIP protocol, you can use any protocol, not only RIP. Okay, so RIP protocol is to be used for which port, 11.0.0.0 to be added, and 192.168.3 dot network, only neighbors will be adding, right? Yes, added. Then go to settings and save them. Done. This is the basic topology settings, everything is in green. Now we will try to send a packet and see whether we are able to access everything. Now we will start with the ACL process. Up to this it is only basic process, you could do by yourself. From here onwards we'll do the ACL statements. Okay, before doing the ACL statements, let me verify that whether I am able to ping everything. I'm going to first PC IP. I'll check the IP first. IP config, it is 192.168.1.1. you can observe here. So I'll try to ping the same network 192.168.2.1. I should get reply. Yes, first packet was timed out, second packet onwards I am getting the reply. Okay, next I'll try to ping the second network 192.168.2.1. yes, very good, I'm getting reply. It is not blocked since I have not done any ACL. Next one is ping 192.168.3 dot network 3.1. I should get a reply. First packet may be lost, second packet onwards I should get reply. Yes, correct. So I am able to do everything. It is possible to send a packet across the networks. I'll do it in the real-time mode also. See, from the PC1 I am sending it to PC4, that is 1.1 to 2.1. it is successful. So from 2.1 to 3.2 it is, first packet may be failed because of that ARP request. Second packet should go. Yes, it is successful. Now it is done. Now we are going to write an ACL statement for our conditions. Okay, that is 192.168.1.1 should not communicate with 192.168.2.1, that is 2 dot network. Second condition is 192.168.1.2 should not communicate with 192.168.2 network. The last one is the 3 dot network 192.168 3 dot network completely. It should not communicate with the 192.168.2 network. So this is our condition. All other things can be permitted. So I have decided already that this router I am going to check. I'll write the ACL statements on this router. I'll go into this router and start writing the process. Okay, I'll go into the router, go to CLI. In the CLI I can write it. So I should go with the configuration mode. So in the configuration mode I can write the ACL statements. We know the syntax. Let me show you. The syntax is access list. We need to write the access list number. If it is a standard ACL, it must be 1 to 99, and permit or deny statements you should write. Then IP address and wildcard mask. The second one is access list, ACL number, and permit any. This will be the last statement, and we should give the interface on which port I'm going to choose, and I should give the access group list. Okay, we'll see it now. Okay, fine. So first statement is access list. Okay, I'll take some number 15, access list number 15. Before that I'll show you, see, if I'm writing question mark, I am able to see 1 to 99 is standard access list. So I'm taking a number between 1 to 99. So access list 15, then deny or permit I should write. So it is deny. What I should deny? 192.168.1.1 specific host. Okay, specific host. If I am writing, I should write the wildcard mask as 0000 1 2 3 4 5. I have written 1 2 3 4. Okay, so next one, what is the second statement? Access list 15, the same access list number should be used. Deny. Okay, 192. So I'll show you one more thing. If I don't want to write this wildcard mask, I can write it in a statement like deny the host. Only the host number I can write 192.168.1.2. That is also correct. So either I can write the wildcard mask, otherwise I can write a command called as host. Okay, for a single host to do this one. So third one is access list 15. What I should do? I should deny the complete network. I should deny which network? 192.168.3 dot network. I should deny. What is the wildcard mask? It is nothing but the opposite of the subnet mask, 0.0.0.255. Then that's all. I need to write the access list, permit any. Something is wrong. I forgot to write the access list number. It is access list 15, permit any. Yes, that's all. We have written the access list numbers, access list, everything. Now I should write the in-out, which is inside outside direction I should give. So we have decided that we are going to implement on the this port. Which port is that? We'll see it. So this is the port we are going to use. This port is gigabit Ethernet 0/0. That I should mention, and it is going to be the outside direction. That I need to mention and see. So does interface gigabit Ethernet 0/0. Okay, then IP access group, that number which we have used the access list number I should write here, and then in or out direction out. See, if we are confused whether we are in the in direction or out direction, you can try both. First you can do it for in. If your conditions are not satisfied, then you can do it for out, but it is not advised that to do that. It is just a trial and error method, what I have said. This is how we need to see carefully and then decide whether it is in or out. Okay, then we can end this. That's all. Now I can see the access list with the show command. So access list SC here. So deny the host 192.168.1.1 is denied, 1.2 is denied, and complete 3 dot network is completely denied. correct? So I'll actually see the running configuration also. Show running config. So the running config, you can see whatever we have done, everything. We have given this. So you can see this is the access list commands what we have given. Host. So even in this place, for the first command I have given the subnet mask, it is not taken. Instead it has taken the command in a host. So you can write this command as well, no problem. That's all. We can close this now and close this. Now we'll see whether what we have done is correct. So earlier we have seen that all the networks are able to communicate with each other. So again I'll go with the first PC only. I'll try to ping my own network first. I'll check 192.168.1.2. it is getting reply, fine. So next, if I am pinging to 2. network, it should not get reply, correct? So we'll see 192.168.2.1. yes, very good. I'm not getting reply, it is destination host unreachable. Next I'll try to ping 3. network, it should allow. So I will see 192.168.3.1. I should get reply. Yes, I'm getting reply. So there is a communication between 1. and 3. but there is no communication between 1.1 and 2. network. I'll see if I am able to communicate from the 1.4, because 1.4 is permitted to send packet anywhere. So it only 1.1 and 1.2 was blocked as per our ACL statements. So 1.4, I'll try it out once. Okay, ping 192.168.2.1. yes, I'm getting reply. So very good. So I'll go with 3. network now. One PC, I'll go and try it out. So in this PC I should not able to communicate with the 2. network 192.168.2.2 or 2.1. yes, it is not able to communicate. Destination host is unreachable, but I should able to communicate with the 1. network 192.168.1.1. yes, I'm getting reply. Yes, now it is fine. It is fine. So real time we'll see once if I'm sending a packet from 1.1 to 2.1, it is failed. But if I'm sending a packet from 1.4 to 2.1, it is success, correct? So if I'm sending a packet from 3.1 to 2.1, it should be failed. If I'm taking a packet sending from 3.1 to 1.4, it is success, correct? So this is called as ACL statements. What we have used is numbered ACL. We have taken number 15. You can take any number between 1 to 99, but the same number should be used completely. This is all about the ACL statements. In the next video we'll be discussing about the network address translation. While discussing the network address translation, this is ACL will be a portion of that. We'll see that in the next upcoming videos. If you have any doubts, you can post it in the comment section. Thank you.